Hello, in this SFML video, we're going to be looking at the event system. We're going to be handling window events, we're going to be handling joystick events, mouse events. We are also going to be handling keyboard events as well. We're going to be handling all the different type of events that you will need to create your awesome game. First of all, if you have followed the setup video for Visual Studio, aka Windows, you probably don't have this code here unless you've added it yourself. If you haven't, then you won't have this code. If you follow the Mac setup video, you already have this. This is the event system. The reason you have it if you're on a Mac is because Mac requires you to handle at least one event, which is the window closed event, aka when you click that X in the top right on Mac. Actually, I mean top left on Mac and top right on Windows. On Windows, you don't have to technically handle this event before you can actually get it to compile. So that's just the reason why I've already got it. But I'm actually going to get rid of it and go through exactly what we're doing. So the first thing we need to do is in the while loop is do SF event and just generally just call it event. And this is the event that has occurred during this iteration of the while loop. The general game logic or the general way to handle your while loop for your game is to have any events, so such as input, then update the game logic based on input, and then draw the screen or draw the new contents to the screen. So an example could be if I click the left key, that could be an input event that's handled, and then if the left key is pressed, I can move a character left by X amount depending on how long I've pressed the key. That's the update part, and then I would clear the screen, and then the drawing part would be drawing the player in the new position along with any other assets such as background, any UI, that sort of stuff. So once you've done SF event, to actually check an event you need to just do a while loop. You can handle it with another loop if you really want to, but a while loop is the best one to use. And you want to do window.poll event. So the window is whatever your render window is called, and in here you just pass in event. So this essentially just checks for any events that are occurring every iteration of this window.isOpen while loop. And the first event that we want to check for is the one that I already had, which was if the X button is pressed. To check for any event, you can either use a switch statement or a if statement. We're going to use switch, and we will show you how to do an if statement as well with it. So if I do switch event.type, so this just checks the event, and I've just misspelled event. So this is checking what type of event has occurred. The first one they should always handle is SF event type closed like so. Put a colon. Then afterward, just put like a break because you don't want any of the cases to cascade down. And then you just do window.close. So if I were to run this now, we get our application as usual, and if I click X, I can close it. But if I were to comment out this line and not actually put anything here, and if I were to run it now and click the X, though I'm technically handling the event, I'm not actually doing something when it's being pressed. So another great thing about using this case is maybe you want to save some data or do something before you actually close the window. So this is a great way of doing that. So you just do that before the window.close. So that's a pretty basic event. The next event is the resized event, so when the window has been resized. So FF event, and what I want to show you is you don't have to technically do event type. You can just do event and then the event that you're handling. The reason I prefer to do event type is because of this. If I go here and I'll put 2 colons, there's event types, but there's also bunch of other stuff that aren't event types which wouldn't work in this switch statement. Whereas if you put event type, you only get things that can be handled in this switch statement. So it's a great way of just specifying the exact thing that you want and seeing exactly what can be covered, and we'll be covering all of this as well. So like I was saying, we're going to handle the resized event, And all we're going to do is just do std cout event dot size dot width. So we're going to get the new width of our window, and we'll get the height as well, so you can see the updated values. So event dot size dot height std end line. Again, just put a break. If we run this now, see what we get. Okie dokie, so as of now, nothing. If I open up the console, still nothing. But if I resize it, still nothing. But the actual event doesn't trigger until I actually let go. So as you can see, it's got the new width and height. And if I were to drag this down, try and keep the same width roughly, the width hasn't changed that much, but the height has increased. So it's not a live counter of the user changing the size of the window. It's just once it's occurred. Generally speaking, this event probably won't be used that much. If you're using OpenGL with this, then you'll probably want to use it for handling the viewport changes. But apart from that, it's not an event that is used very often, but it's still good to cover it. Next event we're going to cover is the lost focus and gained focus. So case SF event type, and this is going to be lost focus. And what I'm going to do is std cout, and you don't really know what this does. This essentially just triggers when you are no longer focused on this particular window. So if I'm focused on Xcode now, if I click on the desktop, I'm focused on the window, so I've lost focus. If I click on Xcode again, I've gained focus on to Xcode. So this is essentially what this line is covering. So I'm just put a break, and so that's lost focus. Copy and paste that. And for gain focus, we'll just change this to gained focus and change this to gained focus as well. So let's not gained or gained, it should be gained. So let's run this and see what we get. So if I click away, lost focus, click it, gained focus. It's not based on whether the mouse is in it or not. That's a separate event, and that's a mouse event, which we'll be covering later on, but it's whether or not we have lost and gained focus. A use case for when you would actually want to implement this is if you lose focus, you could potentially pause the game, and maybe if you gain focus, you could resume the game. So that's something that you could do with this one. The next one we're going to handle is text entered, so we can see what text has been entered. So this is great if you're actually getting some sort of text input, maybe for a high score. And to handle that, just paste this in because it's going to save so much time. Just change this to text entered, and now to actually get the actual data that has been entered, you put if event.text.unicode. If this value less than 128, then it's a valid ASCII character, and then you just do std cout, and you do event.text.unicode like so, std end line. And now if I were to run this, let's see what we get. So if I click the H key, we get 104. If I click A, we get 97. If I press Shift and A, we get 65. These are ASCII values. But what if we want the actual, well, the character that's being pressed? You can get that by casting the Unicode value using static underscore cast, and the type you want to cast it to is a char, like so. And if you cast Unicode by putting it into brackets, if we run this now, we'll actually get the character instead of the ASCII number itself. So if I click A, we get lowercase a. Press Shift A, we get uppercase A. If I press H, as you can see, we get the characters. If I click Shift Control, that does not get picked up. You can handle that using the key pressed events, which we'll be covering next. And a lot of developers actually do some really complex, crazy stuff with the key pressed and key released events to try and handle text input. There's no need for that. just leave all of the key press key events just for the game logic, and use the text entered just for, well, when you are actually getting text from the user for stuff like high scores. And what I'm going to do is comment this out, because we'll be pressing other keys, so start conflicting in the console, so it'll be hard to see what we're doing. And now we're going to check for the next event, which is the key pressed event. So if I scroll down, paste this here, and this is key pressed. So we're going to do std cout, and I'm going to say key has been pressed, std end line, break. Now if we run this, if I press a key, it says a key has been pressed. Even when I press stuff like Control and Shift, this handles those events. It's pretty cool. So apart from at the start of a game where we might say press any key to continue, this isn't that useful because we need to actually detect what key has been pressed. To do that, you just do if SF keyboard, and now the key that you want to actually check, there's a bunch of keys here. So if you want to check A, you would obviously put A, and I'm going to put left for the left key on the arrows. So if this is equal to the event.key code, and if you just want to see what the key code returns, you can enclose this in a cout. Recommend doing that as an extra task just to see what this returns, but just to actually see if this key has been pressed, this is all you need to do. I'm going to do std cout, and we're going to say left key has been pressed. I'm going to do std end line, like so. So if we run this now, we have this window, and if we press some random keys, I haven't pressed the left key yet, just pressing random keys, key has been pressed. If I press the up key has been pressed. If I press the left key has been pressed, and left key has been pressed. So that's pretty cool. We can also detect for if the Control, Alt, Shift or System keys have been pressed. To do that, you just do std cout, so Control, and you put event.key.control. This just returns a boolean, so it just says whether or not this key has been pressed alongside the Control key. And if I do std end line, and if I copy and paste this, so you have we have 4 instances of it. So you can check for Control, check for Alt, Shift, and the System key, aka the Windows key or the Command key on Mac. You just change this to Alt, change this to Shift, not Shirt, Shift, and System. So if I run this now, and let's see what we get. So if I click Shift S, as you can see, if I'm clicking Shift, it says Shift is pressed. If I click the Command button, the System flag is now white. If I click Alt, Control, and so that's pretty cool. I'm going to try and press all of them at the same time. And which one did I miss then? Press Control, Shift, Window, and Alt. There we go. All 4 triggers have been pressed. So if, let's say, you wanted to move the player with the up key, you could use something like this. You just have up here, but maybe the player can run if you press the Shift key down. So what you could do is say if SF keyboard up equals event.keycode $&, aka and event.key shift, then it will only trigger that particular if statement if the Shift key and another button has been pressed. So now let's handle when the key has been released. Very simple. It's the opposite of this. So we're just going to copy this, and we're going to say key released. The only thing we're going to change is this to released, this to released. So what we'll now get is if we run it, when we press the left key, we're going to press some random keys. So he's saying if I press the H key, has been pressed, but if I let go of it, it says released. And if I click the left key, it says left key has been pressed, left key has been released. So that's how you handle the released event. Something I want to show you, if you pay close attention, if I'm just going to press the H key, it doesn't really matter what key I press at the moment, it says pressed and then released. It's doing one pressed event, then one released event. One pressed, one released, one pressed, one released. But if I keep the key pressed for quite a while, it does multiple pressed events. You might want that. Generally speaking, if you want some sort of input like that, you need to use live input, because that is better, because the amount of times it will get triggered in the event system is predetermined by the OS. So events are just good for, the single event. So if you're clicking something, if you're moving something, just the really simple stuff, and you want to use live input for game logic. So if you're pressing the left key and the character moves left, that's what you want to use live input for. So if you want to disable the event system from allowing you to trigger multiple times on the key press down, you just do window, and this goes before the while loop, dot set key repeat enabled to false. And if I run it now, and if I keep H pressed, it doesn't do anything till I release it. Simple as that. So I've already just mentioned that because that's something pretty useful to know. The next event we're going to be covering is the mouse button pressed event. So if I copy and paste this down here, and I'm going to put a break, I'm going to change this to mouse button pressed. I'm going to put std cout mouse button pressed. I'm going to do a std end line, and it won't run because I didn't put a semicolon. If I run it now, works fantastic. And if I click the left mouse button, it picks it up, right mouse button, it picks it up, middle mouse button, it picks it up. So we want to handle a particular sort of mouse button. So to do that, just do an if statement, and in here put sf mouse button, like so. It's very similar to what we did with the keyboard keys. So instead of doing stuff like keyboard left, we would just do something like mouse button, and for this I want the left key, the left mouse button, and if this is equal to event.mouse button dot button, and again I would recommend just cout in the button here just to see what sort of value you're getting relative to this value that you're comparing it to. Put std cout and put left mouse button pressed, std end line, and now if we run this, let's see what we get. So I click the right mouse button, so that is a mouse button pressed. If I click the left mouse button, it said left mouse button pressed. So that's fantastic. But what if we want to handle mouse button released? I think you can guess it's essentially the same process. So I can just copy and paste this, change this to mouse button released, change this to released, and this one to released as well. So if we run this, so if I click it, it says mouse button pressed, left mouse button pressed, and then the released event. If I just click the right mouse button, it just has the pressed and released because we haven't done an if statement for it. Now let's handle when you have scrolled your mouse wheel. So to do that, you just do case sf event type mouse wheel scrolled std cout mouse wheel is being scrolled std end line, and if we run this now, we'll get mouse wheel is being scrolled whenever we scroll our mouse wheel. So as you can see, mouse wheel is being scrolled. But if we want to get a value from it, you just do std cout event.mouse wheel scroll, do dot delta, and this will allow us to determine the speed of the scroll and the direction. So if we run this now, and if I scroll, as you can see, we're getting negative values. So I'm scrolling very slowly because I'm actually scrolling down. But if I scroll really fast, we get high values. If I scroll slowly up, we get low values, but they're positive. If I scroll up very fast, we get very high positive values. So that's a way of determining what direction the mouse wheel is being scrolled. So if you want to detect scrolling up, greater than 0, scrolling down, less than 0, aka a negative number, and the higher the number, the faster you're scrolling. So that's scrolling handled. Now let's detect when we have moved our mouse. To do that, you just do case, copy and paste this, saves so much time. And the event is mouse moved. Actually, I just want to cover something. There's also mouse wheel moved. That's the same as the mouse wheel scrolled, but mouse wheel moved is just old deprecated code that hasn't been removed from SFML yet. The recommendation is to use mouse wheel scrolled instead of mouse wheel moved. But if you're on an old SFML version and you're watching this video, you might only have mouse wheel moved. And if for whatever reason you can't update your SFML version, just use this one and it will handle the same way. So if we do mouse moved, this will detect when we just moved the mouse. And in here, we're going to do an std cout event.mouse move.x. So this will get the x position. We're going to just put a colon. And we're going to do event.mousemove.y std end line, and this gap here is bugging me, so I'm going to get rid of that. For a break statement, run this now. Okay, so it's moaning about something. What's it moaning about? So we got the cout event mouse move.x. Forgot the two symbols here. Fantastic, it's built. So if we move it only within the window, it doesn't detect the outside. So in the window, top left will be 0, 0. So if I can get pretty close to, I've got to 0, 0, and the bottom right will be 640 by 480 because that is the size of my window. So as you can see, right is a positive x value or a great x value, and left is a lower x value, down is a higher y value, and up is a lower y value. Pretty basic stuff. Now we're going to handle if the mouse has left or entered the window. So let's just copy and paste this. So this is when the mouse has literally just exited, not lost focus or anything, just when it's no longer on the window. So this is mouse left. I think it should be called mouse left window, mouse outside the window, because mouse left almost hints like it's the mouse left button, which is the most popular mouse button, a very popular button in computers in general. And put std cout, and I'm going to put mouse has left the window, mouse has left the building. Now, mouse has left the window, std end line for a break, no BVR, break. And I'm going to copy and paste this for the mouse entered. So this is just the opposite. Mouse has entered the window. Run this now. So if actually, because this is going to start conflicting with it, because every time I move it, I'm going to rerun it so we can easily see the coutts. So I move in, mouse has entered the window, left, entered, as you can see. But it is different to me clicking away and me clicking onto the window itself. So that's the mouse event. Now we're going to cover joystick events. Joystick events will come in several different forms. They might actually be an actual, I don't know why I went on incognito, but it could be an actual joystick, for example, which would be something like this, the old conventional joysticks for the flight simulator games, the X-Wing games, that sort of stuff. Or the joystick events can be used to just check for input from a game controller. I have a PS4 controller here with me, and we're going to be detecting events for that. But if you've got a 360 controller or an actual joystick, it'll be the same process. So first of all, let's just detect if a joystick button has been pressed. So for that, we're just going to do case SF event type joystick button pressed, and I'm going to do std cout joystick button pressed, and do std and line break like so. And if we run this now, I'm pressing buttons on my joystick and it is picking it up, so which is fantastic. As usual, we want to be able to detect what button has been pressed. So this is a little different to the way you would do it in something like the keyboard event. You would, or the mouse event, you would do SF mouse button left. If you were to do SF joystick, you don't actually have buttons necessarily on here. You have just the buttons will range between like 0 and the maximum number of buttons supported, which is actually 32, and how many buttons you can actually pick up from your controller. So you would have to code it in a way so it maps to a particular button, but we'll show you that right now. So first of all, let's just see out the joystick ID, and the joystick ID is just which joystick is being detected, and this just returns a number. So if you do event.joystick button .joystick ID std and line, and if I run this now, if I press it, we get 0, and what this is saying is this is the first joystick, aka the joystick assigned with the number 0, and if I were to connect another controller in, you would have a joystick ID of 1, 2, 3, 4, and it supports up to 8 different joysticks, which is realistically more than enough, even for some of the WWE games. Remember back in the day with the WWF games on the PS2, you'd get that multi-controller adapter, go around my cousins, and they would just have a bunch of controllers, and it would just be a mess. I'm not talking about in the real world, talking about in the game. You would not know what was going on. Things would be flying, you'd be hitting people over the head with stuff in the ring, and it was fun, but it wasn't like a serious game or anything. Just some cool as fun. So let's just copy and paste this. So we want to detect when a key has been released. So let's put released. I forgot. I haven't detected when a button has been pressed. So if I do std cout joystick button, and this is going to be event.joystick button std and line, and I'm actually going to first of all I need to fix this, copy and paste this because we'll use it for when the key has been released as well. We'll say joystick button, and we'll just put in brackets released and pressed. So if we run this now, so if I click a button, it says the ID, the number 1. If I click another one, it says 0, it says 3, 2, 11, 10, 13, 4, 5, 6, 7, 12. So on my PS4 controller, the X button, aka the button that is at the bottom of the face buttons, if I click that, that's number 1. So if you assign number 1 for maybe jumping, which is very common in a lot of games, such as Crash Bandicoot. Maybe square, which is the left button on the face buttons. That is 0, so you would assign 0 to do something. And in Crash Bandicoot, it would be something like spinning around. Triangle will be bringing up the UI on Crash Bandicoot to see how many lives you got left. And if you say 0, or if you say 1, you know you got 2 lives technically. The current one and 1 more. So that's the joystick button released. Now let's handle when an actual, thingy has been moved on the joystick, one of the analogs. So just do case, event type, joystick moved, and I'm going to put std cout, joystick has been moved, std end line. And if I run this now, let's see what we get. So I'm moving the joystick and it says joystick has been moved. That's pretty cool, but we want to actually detect which joystick, and on top of that, we want to detect by how much. So to detect which joystick, you do if ff joystick axis. This is something that you'll have to play around with a particular joystick, or the joystick you have. If I put : there's some different axes that you can deal with. If I put X, for example, event.joystick move.axis, and in here I'm just going to put std cout event.joystick move.position std end line. And if I run this now, pick up my controller, I'm moving the left joystick. You know what, I'm going to get rid of this because this is just conflicting with the other cout. It's just hard to see. So if I move the left joystick left, it goes to -100, then to 100. So that's just detecting the x-axis, okay, left and right, the horizontal axis on my left joystick. If I click move the right joystick, it didn't do anything. So maybe we want to handle another axis. So let's just put y. So let's see what axis this will handle. So this is handling the y-axis. Okay, the vertical axis up and down on my left joystick. So as you can see, moving up is -100, moving down is 100. If I do it very slowly, moving down, go all the way to 100, or I'm going back now to 100. And yeah, that's it. I've showed you how to handle the axis, and I'm going to leave it to you to have a look at the other axis and see which ones are assigned to your different sticks and what direction they go. But the code is exactly the same. You would have multiple statements if you're handling multiple directions, aka vertical, horizontal, different sticks. You can do all of that here. The last thing I'm going to show you for joystick events is detecting when the joystick has been connected and disconnected. To do that, just put case, sf event type, joystick connected, put std cout, and I'm going to put joystick connected, std end line, for a break. And if I copy and paste this, if I run this now and I put joystick disconnected, and I put disconnected, run this now, my joystick is already connected, so it doesn't actually do anything. If I disconnect it, joystick disconnected, and if I plug it back in, connected, disconnected, connected. So very simple stuff. So I did say that I would show you how to handle these events without a switch statement, and you would do that. So outside of this switch statement, either before or after, I'm going to do it after, you would just put if sf event type joystick disconnected, for example, that's the event I'm going to handle, dot type So you would have to check if it's equal to event.type, because that's essentially what the if statement is doing. Then you would handle, so you would do something here. So this is the equivalent of this within the switch statement. And that is it. So you might be wondering, how do you detect multiple events at the same time? I'm actually going to leave that as a task for you. There will be a link in the description to the GitHub page, which has all of that, and it shows you how to detect if a key has been pressed, and let's say if a mouse is moving at the same time. A little clue, you'll be wanting to use if statements, and you'll probably want to be using Boolean flags as well, combined with the switch statement. But like I said, we've got all of that code on our GitHub page if you're stuck with that, and there'll be a link in the description. If you liked the video, please give it a thumbs up, hit that subscribe button, and leave us a comment. If you got any questions, feel free to post them on our educational platform, sonarlearning.co.uk. There will be a link in the description. And as usual, thank you for watching, and I hope you have a great day.